Okay, so we've dealt with about 40% of our non-volatile acids. That still leaves 60% if you're a math whiz. So what do you do here? You have to have something else be part of the process. In this case, we have NH3 and NH4 that's going to take care of the rest of these non-volatile acids. So this ammonia-ammonium response is very important. You utilize the same kinds of mechanisms, this sodium hydrogen ion exchanger, and what you'll do is you'll pump some of the NH4 out through this exchanger. Where does that come from? It comes from metabolism. The NH4 comes from metabolism. A little bit of NH3 is formed as part of this reaction involving alpha-ketoglutarate. NH3 is not charged enough and will be able to move through the membrane. NH4 has a charge and therefore has to be exchanged through this transporter. So whether you use NH4 or NH3, it's not important. That's just how you're getting the molecule out across the apical membrane. You notice when you have made an NH4 or NH3, a new bicarbonate is also formed, and that gets pushed across the basolateral membrane and reabsorbed by the blood. Therefore, you have NH4 of being your excreted acid. So it doesn't matter how you get it there, either the NH3 by itself, bind it with a hydrogen ion, or kick out an NH4. You will lose it as NH4. This involves about 60% of your non-volatile acids will be removed in this manner. It's all done in the proximal tubule. The other important thing about NH3 NH4 is that it is highly adaptable. If you have a chronic acidemia condition, this NH3 NH4 mechanism upregulates. Your titratable acids don't. They pretty much stay the way they are. But this ability to increase the amount of hydrogen ions you can kick out across the apical membrane through NH3 or NH4 can increase to help you adapt to that environment. So when you think about the amount of millimoles that we started off with let's say 70 millimoles of non-volatile acids, about 30 millimoles of that were taken care of through our titratable acids in the proximal tubule, the distal convoluted tubule, and the collecting duct. About 15 millimoles in the proximal tubule, about 5 millimoles in the distal convoluted tubule, and about 10 millimoles in the collecting duct were taken care of by our titratable acids. The other 40 millimoles were taken care of by NH3, NH4.